broadcasting after all. Well, thank you for that introduction. It's wonderful to be here. I can't see any of you, but hopefully you are all still here. My name's Mike. I'm CTO at a UK-based prop tech company called StuRents, and it's great to have quite a few of our team here with us today. And if you want to interact with me, you can either talk to me after the talk or through the conference, or you can follow me on any good Fediverse instance. I'm at m1ke at phpc.social. My talk today is called Your Software is Mission Critical. But first, who remembers this? The double rocket landing of the SpaceX Falcon Heavy rocket. For those of us who watch this live, you will remember not only being amazed by the process of these rockets coming down together, but just how smoothly everything went. For things like this, not just the landing, but the entire spaceflight process, software is not just essential, but must be absolutely perfect. The thing is, for many people, the experience of software is a bit more like this. Head in your hands, wondering why it's gone wrong again, such as why my toolbar has appeared on the side of the slides. We don't know, but these are the things that happen. Or maybe it's something like this. This was a quote in an article in the New Yorker last summer. People were noticing that there was something about these systems that had an impact on their lives. This article was called The Age of Algorithmic Anxiety. The fear that people had that algorithms that they didn't understand and that they didn't trust to have their best interests at heart were somehow spoiling their lives. And they were anxious about this fact. And when we look at these things, this view people have of software, we have to wonder why they have that. Why has that become the state of software today? I think in one part, attitudes like this might be to blame. Move fast and break things. Unless you are breaking stuff, you are not moving fast enough. Now, this quote, attributed to Mark Zuckerberg, popularized in the movie The Social Network, has, I think, typified software development over the last decade or maybe more. And it was a strange thing. When I was looking for this image to put in my slideshow today, every time I found this quote, it was against these sort of Zen, wellness-like mindfulness backgrounds. And I didn't feel that was appropriate. So I've made my own. Now, the thing is, it's easy to dunk on Mark Zuckerberg, and so I'm going to continue. But we all know one thing, and that's that we are the people who build software. The people here in this room. And the reason I'm opening this conference with this talk is because I want to encourage us. We're at a brilliant place for the next 2 days for learning, for gaining experience in how to do things that we've not thought about before. And I want to encourage all of us to see just how important that is, to see how helpful this conference can be to the way that we interact with what we do and the way that what we do interacts with the world. And so, let's get on with it. So, why mission critical? Well, mission critical is not something that has a canonical definition, but it looks good in a talk title, and hopefully when you all saw it, you came. I mean, you're here, right? And I wanted it to evoke an image like this. This is the Airbus A380, the largest commercial passenger jet ever created. It was ultimately an unprofitable aircraft for Airbus. One of the main reasons for that was significant delays in its production. And in this huge aircraft, a double-decker aircraft, 4 engines, a huge amount of metal, one of the biggest challenges in building it was getting the software and the electronic systems to talk to each other. When you have something like an aircraft, software is mission critical. And as a sad illustration of this point, we have another aircraft. This is the Boeing 737 MAX. In late 2018, early 2019, 2 Boeing 737 MAXes were involved in fatal air disasters, killing everybody on board. In the subsequent investigation, one of the key factors in both crashes was determined to be the autopilot software, which had fought the pilots all the way to the ground. When mission-critical systems fail, people tend to be on the losing side. At this point, you might be thinking, well, I don't build autopilots, and we're at a PHP conference, so that makes me quite happy. But the thing is, software is everywhere. It's in healthcare, finance, defense, transportation, things that keep the world running. It's also in the really boring, everyday stuff. Interacting with the government, paying our bills, buying food and education. And it's in the way we get away from the world. Cat gifs, social media, 27 different streaming services, why won't they stop? And of course, more cat gifs. And this is where I have to bring back our sad-looking man. And I'm going to give him a name this time. I'm going to call him John, because this story I'm about to tell you is about a real person called John, who I know. And John was buying a house. You know, buying a house is a pretty significant step in anyone's life, especially at the moment. But he was in that process. It's a long process. It's a complicated process. It's a stressful process. And as part of the process of buying a house, he wanted a simple request, which was that when he moved in, he wanted to have internet access. And like many of us, John worked from home. Internet access, pretty important when you move into a new house. So John called up a company and asked them for one of their finest internets and said it needed to be delivered about the time that he was moving into the house. He didn't quite know, but it was going to be a few months at least. They said, yes, we can do that for you. Get back in touch when you know moving date. And he moved on with all the other things you have to do to buy a house. 2 months later, John gets a phone call from his bank to tell him that they've withdrawn his mortgage offer because of a sudden and unexpected fall in his credit rating. When he drilled into this, he found out that it was because of unpaid internet bills. The company that he'd called up and asked to provide internet had been billing him at the house that he didn't live at. So he hadn't been receiving these bills for an internet connection he wasn't using at a house he didn't live at. And the subsequent strike on his credit record for not paying his bills lost him his mortgage offer. John went from the heights of buying his own house to being practically homeless, all because of a software system. What's the problem? We can summarize this as mistakes made in software development lead to errors in live usage of the software. But the result on people is much deeper. Anxiety, loss, stress. At this point, it might be easy to say, well, the software was the problem. The software was the issue. The software let them do a thing that they shouldn't have done. I love this quote from Mitch Radcliffe: "A computer lets you make more mistakes faster than any invention in human history, with the possible exception of handguns and tequila." Last time I gave this talk was in Texas, and that got a bigger laugh. And that's what we're looking at here today. The computer lets you make mistakes. You're still the one making them. It empowers you to make them faster at web scale, but you're still the one making those mistakes, and they still have an impact. Before we get into the rest of it, I want to do some clarifications. What we're talking about today is how we build software and the unintended negative impact of that. There are cases where people build bad software or build benign software and sell it to bad people. And there's great talks and great books written about those facts. They're worth looking into. This talk isn't about that, and we're not going to cover that area, because I'm assuming, hopefully, the general case that most of us are not trying to build bad software to do bad things, or selling our software to bad people. The majority case, our software is good to neutral. But that still doesn't prevent indirect harm. We can still make mistakes with how we do what we do. I believe that it's our responsibility as developers to get this right. So, how do we do that? Well, number one is testing. There's a surprise. It turns out everyone has a test system. Some people are fortunate enough to have a separate production system. And in this conference, again, there's talks on testing. I advise you to go to them and learn about this thing, because it's very important. It seems obvious that if we don't test, things break, and yet it's something that often gets skipped out. During this talk, I want to look at the mission-critical way of doing things and see how that can inform us. The Federal Aviation Authority in America has a number of guidelines, as you might expect, for aircraft and airline systems. And they're written in a sort of jargon, very dry format, but I'm going to read a few of them out. In this one, it says processes must have well-defined entry and exit criteria, according to DO 178C, and a project must show it's respecting those criteria as it performs the activities in the process. Now, helpfully, the language in most of these documents is so dry that even the aircraft software community has taken it upon themselves to provide summaries of these. And I found a website that was doing just that, and they said this: say what you are going to do before you do it. And people might recognize this as test-driven development. In test-driven development, if if you've not come across it before. You write a test for an expected outcome. You then write some code to pass the test. And then you make the code nicer, whilst ensuring the test still passes. That's known as refactoring. And test-driven development is a great principle. When people hear about it, they see the value in doing it. But it can be much harder to put into practice than in a theoretical exercise. What about our legacy projects, the things we've been working on for a long time, which, let's face it, is what most people are doing. The code you wrote yesterday is already legacy. In testing, there's a traditional pyramid of the type of test you'll have in a system. At the bottom, we have our unit tests. The unit tests are the most numerous, hence they form the foundation. They test the smallest different parts of our system and how it interacts. Then we'll have service tests or integration tests, connecting a database or a file system, maybe an external API. And finally, at the top, we have our UI tests, our user interface, end-to-end acceptance, browser. There's loads of words for the UI level. We'll often have the fewest of these. They tend to be the most complicated to write. They tend to be the most brittle and break often. And they tend to take the longest to run as well, because you're simulating real user actions. And so, together, these form a pyramid of our base and our top level of our tests. But I find this sometimes hard to apply if you're bringing tests into a system that doesn't have tests yet. So I've tried to adapt it a little bit to cover some things which might help people. Step one is to actually test some stuff. The foundation of your testing strategy doesn't need to be a specific type of test. It needs to be the fact that you're starting to do testing of any format. In fact, in a legacy project, you might find that your UI or browser tests are the best place to start. Hopefully, you have an application that at least works for some of your users. So simulating their behavior in a test format is a really great way to start adding safety to your application. Once you've done that, you can start changing internals to allow it to be used for unit or service testing without thinking you'll break the whole thing for everyone. Once you have tests built, any of those tests, you want to look into continuous testing. And by this, I don't just mean hitting enter repeatedly. Continuous testing using a system such as GitHub Actions, Bitbucket Pipelines, CircleCI, Jenkins, there's many others, and again, there's talks on that in this conference, are great because they can run your tests every time someone pushes a commit, every time someone opens a pull request, every time you want to do a deploy, various strategies to ensure that these tests keep running. If you don't keep running them, they'll go out of date, or they'll break, or what's the point in having them? And finally, increase our coverage. Once you have this base of your pyramid built, you can look at actually increasing the coverage. How many parts of your application are you covering? And there's ways to improve the coverage of our testing. Collecting metrics. Tools such as PHP Unit combined with Xdebug can give you code coverage statistics on how many lines of code are run in a test run. Targets in your pull requests. Tell people that for every pull request, either new code must be covered by tests. Maybe not the old code, maybe new code. Maybe every pull request has to cover a little bit of old code as well, just so people start to move the needle. And I would suggest for teams who are getting into testing to avoid covering brittle features, things that might break a lot. Ideas in this area are things like in a browser test, where you might say, click the submit button. And then someone thinks, submit's a bit of a weird computery jargon word. Let's change it to save, that's nicer. And then your tests break. There's no quicker way to put your team off testing than making simple, helpful changes in your application, break the tests, and require everyone to do the work twice. So think about when you bring this into an organization, think about how you're going to encourage people that testing is a good thing, not just something that gets in their way and slows them down. It will maybe slow down a little bit, but let's not frustrate people. Or we can take a different angle, another mission-critical way. When I was studying for my degree back in the 2000s, I remember reading about a piece of software that was able to mathematically verify every possible runtime outcome of a computer system. And so I did some research on this when writing this talk, and turns out this software was called ASTREE. This was used in the Airbus A380 to verify the absence of runtime errors. What this means is the software was able to analyze every possible function, every possible input and output, all the ranges, which you might think that's crazy, like integers have a very high range. But they could work out what ranges were possible and what the outcome of every possible input to output would be, and tell you that there will be no runtime exceptions, no e-fatal errors during the operation of this aircraft, because you don't want to be trawling through logs at 30,000 feet. And that's a pretty complicated, comprehensive mathematical system. Probably quite a lot for your e-commerce site. But in PHP, since PHP 7, we have access to a tool called the abstract syntax tree. This allows PHP applications to read the code of other PHP applications and tell you how they're going to behave. And because of that, we have a number of tools, but the biggest ones being PHP-Stan and SAM, which are static analysis tools. They can look at your code without running it and understand all the possible ways that code can go, all the possible data that can pass between systems, and therefore all the possible times you can get an error that you don't expect. They even add new features to the language, such as generics, and they can do other clever things like telling you that if you have two conflicting logical statements, that the code in one of them can never be run. And I would say out of all the things I'm going to talk about in this talk, this is the thing you can use most practically straight away. If you're not yet using one of these tools, go back, maybe in the lunch break, but maybe you can wait until Friday, I'll allow it, and start using one of these tools. There is no reason not to use one of these tools. They both have a baseline system, so that when you first run it and get 10 bajillion errors, you can just happily ignore those, so you can start to improve your project. And then you can do sprints with your team, where we try and smash 100 of those errors in a few days and get that down over time. You will build better software using tools like this, and combined with your testing that makes sure your application works. And what's the benefit of these? Well, tests ensure that code changes don't break applications. And systems build trust by being more resilient. Remember earlier we talked about anxiety. The anxiety wasn't caused necessarily by the system doing the wrong thing at the time. It was people's fear, built up over time, that the systems were going to do something wrong. People have been taught not to trust software systems, that they will go wrong, and that brings in anxiety, worry about what will happen next. So people can rely on software that always does the right thing if we build that resilience into our systems. Now, no testing strategy in the world will help if we've built the wrong thing in the first place. So next we're going to talk about design. Once again, the mission-critical way can inform us here. Back to our snappily titled FAA DO178C article. Once an activity within a process has been defined, it is generally expected that the project respect that documented activity within its process. We should write down how we're going to behave, and then the system should behave in that way. We've defined what we want to do in our system, and the software should then meet those definitions that we've decided on. I looked for some diagrams of different software development methodologies. We have waterfall, considered the old way, and then there's a vague graph that's sort of agile, but sort of not, that suggests a new way. If you notice, the agile graph there is just tacking the end of waterfall to the beginning, so I think it's a bit of a cop-out, and it says sprints in the middle, but it serves a purpose. In both these cases, old way and new way, fully half of the steps are about design. And yet, in actual reality, one of the things that sprint means for most developers is to sprint straight past the design stage. And why is this? I'm not just here to call out developers. There's a reason that we sprint past the design stage, that we ignore it, that we don't see value in it. And I think there's two contributing factors. One set is that when we design something, it's thought out from a very high level, it's written up, and within about 2 days of starting the project, the thing you're building completely diverges from the design because you realize all the problems and the assumptions the design made that were wrong, all the constraints you had to violate to build what you actually needed to build. And so the design becomes this dusty thing in the corner that vaguely describes what you once intended to build and bears no resemblance to the actual product. The other factor is if a design becomes a shackle around you. The design prevents you innovating, prevents you taking the initiative, prevents you doing the best thing. The design becomes this nitpicking, oh, it doesn't do that, what it says in the design. Well, maybe the design's wrong. In both these cases, developers won't see the value of design. You're either ignoring it or you're being controlled by it in a negative way. Design shouldn't just stop when we get to the code. If we want the design to be relevant, to stay as agile as hopefully our development practices are, the design needs to come with us. In the book Domain-Driven Design by Eric Evans, it says this: to create a supple, knowledge-rich design calls for a versatile, shared team language and a lively experimentation with language that seldom happens on software projects. If you haven't come across the term domain-driven design, that's something to look up. And in domain-driven design, as we can see, the issue here is about communication. It's about language. This isn't necessarily about what our code should do at all, but it's about our team talking a shared language. As developers, our language is our code. So the shared language has to involve our code. Our code has to evolve with our design, and our design has to evolve with our code. Our code should describe what our system is doing. We're not people who assign variables. That's not our job. Our job is to build systems, and those systems have a design and a reason for existing. As an illustration of this, a few years ago at this very conference, someone gave me a great expression about an aspect of domain-driven design, which is to make the impossible inexpressible. Our code should be a representative of the real-world factors of our system. If something cannot happen in the real world, either in the real physical world or within our business constraints, our code should make that not possible. Now, a simple illustration of this is the concept of a value object. In this situation, we have a user who has an email address, and hopefully everyone can see the slides, and we'll see that that email is not valid. It's not got a dot something at the end of it. So if you send an email to that address, it won't get there. And similarly, in PHP, at least prior to read-only properties, we could do this. We could pass an object into a function, and we could do something like set the email to an empty string, and the external context has no idea this has happened, sends that email. That email doesn't get sent, and once again, what's the result? And the value object is a way to get around this. PHP's type system doesn't handle email. String is the best thing we can represent it as. It's a series of characters. But we can build our own. In this case, we have our email. We use our best email regex to parse it, and we create our email. And now the user takes an email object. It's now impossible for our system to have a user who does not have a valid email address. Yes, the system will still break when we do create test.email, but it will break at the part where we say, get that email address. And we'll know that that's what was broken. Before we try and send the email, we've never even got close to sending that email to the wrong place. What about in John's case? Bring back our sad man again. Well, in John's case, the issue was another fundament of thinking about design. And it was thinking about what an account is for this utility company. What is an account for a utility company? Well, maybe it's the house that they're supplying the utility to. The house is where the connection goes, but the house doesn't pay the bill. I wish my house did. The bill is paid by a person, by a human. But there is no rule in the real world that says that a human has to live in the same house that they're applying for a utility for. A human can live wherever they want. They can receive mail wherever they feel like. And so in this case, the company had missed something, that the person and the property were different things, and together they made an account. And their system could have reacted in two ways to this. They could either say, well, the person has an address and the property has an address, and the two must match. So we ask you for your address, we ask you for your property address, and if the two are not the same, we say no. You can't do that. We stop them at the point before the mistake is too bad. They might be annoyed, but they've not gotten into debt. Or we make the rule that we send the bill to the bill payer. The bill payer is not the property, it's the person. And in that situation, John's predicament would have been resolved as well. He'd have got the bills to his current house and been able to pay them. So when we look at combining design and testing, good design means we know why we build what we build. And well-designed software understands the use case, understands the real-world constraints in which it exists. So people have their needs met by software that understands them. Now, testing, design. You may be wondering where you're going to bring these things up. How do these work in your own organizations? How can we actually put these things into practice with the various constraints around our businesses? And I struggled a little bit with a title for the next section, so I decided to call it Time, Money, Diversity, and Management. That seemed like a bit of a mouthful, though, so I've just named it Humans. We are humans, and primarily we're building software for humans. Humans are the top-level factor in all of this. That's what we're doing. And in this area, even mission-critical systems are starting to fail. For example, facial recognition used by law enforcement. A recent study published by the AI Now Institute of New York University concluded that a diversity disaster has resulted in flawed AI systems that perpetuate gender and racial biases. Systems that are now being used for law enforcement, for sentencing, for insurance, things that have such a crucial impact directly on people, are failing. Mission-critical systems are failing. And at that point, we might throw our hands up and say, well, if the smartest researchers working on cutting-edge technology can't get it right, what chance do we have? There are factors beyond our control. Who manages us? Who's buying the software? What's making that noise? How will they react to it? How can we influence this? Again, well, it turns out that we have some influence, and it might start with the smallest things. Here's a great GIF, or a little interactive exercise, about how you can have good, fast, and cheap software, but you can only pick two. This is simple, it's trivial, but it explains a point really well. We can show this to the people who manage us, to the people who make decisions, to the people buying our software. If they want the lower price, if they want it faster, are they prepared to cut these corners? Are they aware that they're cutting these corners? We can make people aware of that. And when we're dealing with these complexities, one thing that's going to help or hinder us is the diversity of our teams. Complex software has to meet complex needs of a large number of complex people. It's silly for us to assume that a team that does not mirror that complexity can achieve those goals. And when I talk about diversity, I'm not necessarily just talking about the topics of gender or racial diversity. I'm talking about diversity in every area of economic background, of political view, of age, of educational status. If we want to build good software for humans, we should take the complex and ingenious nature of those humans and mix that together to build solutions that work for everybody. When it comes to solving problems, we're developers. We do that with code. But our main skill isn't writing that code. It's the problems we're solving with it. Can we apply the software principles that we're learning at conferences like this in our day jobs more broadly to the entire way our industry works? We'll often ask a question when we get a bug report. Is it reproducible? Can I reproduce this bug case? What if we ask that more broadly? Do I understand the use case? Do I understand the problem? Do I know what it feels like to be someone trying to apply for a visa to stay in a country with my family when I don't speak the language the system is written in? Does it work on my machine? What biases inherent in the way we've learned, the people we surround ourselves with, are apparent in how we do things? How will it work on someone else's machine, in their context? When we're at a conference, are we so keen to evangelize our way of doing things, our best framework, our best testing methodology, that we forget that other people will have different and yet equally valid experiences? How are we making people feel when they come into the industry? Are we making them toe the line or letting them figure things out for themselves? And finally, have you turned it on and off again? That most classic of software questions. Have you turned it on and off again? Off and on again even. Have you taken some time to stop? To think? To look at the bigger picture? Because if you find yourself moving too fast, you might be breaking things. In conclusion, software is eating the world. This was a statement made by the technologist turned venture capitalist Marc Andreessen in 2011. When this was publicized, I saw it as this kind of utopian future that we were all going to build. Software is eating the world. I must confess, I find it hard to be optimistic about statements like this now. What are we meant to do about world-eating software? I think that after testing, design, and considering the human factor, my final piece of advice here is to be humble. Find good ways to do things, but be open to new ways. Make good plans and be willing to change them. I want to finish with a story of part of an essay from the US writer and activist Wendell Berry. Wendell was building a pond on his land in America. And in order to build this pond, he hired a digger, and he read up on all the different things you need to know to build a pond. He brought the digger onto the hill, he dug the hole, he lined it, he put rocks around the outside, he filled it with water, started putting some plants around the edge, and then suddenly the side of the pond collapses. Rocks, soil, and water spilling down the hill, leaving just a dirty, muddy hole. And because it was on the side of a hill, he couldn't even easily fill it in. In the essay, he says that this left a permanent scar on his land. But it also left a visible signpost to everyone who could come past and see it of something he had learned. He remarks that only in sharing these things with community, sharing this learning of the problems with community, do we make right the damage we cause. He says the trouble was the familiar one. Too much power and too little knowledge. The fault was mine. Thank you very much.
Hello? 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 Yeah, no, you guys can hear me. Hello? Have I got a bad mic again? Hello? Hello. Thanks, Mike. Great talk. Easily the best one I've seen today, so well done. I'm not sure why you kept putting that beeping noise throughout it, but each to their own. We've got a short break now. Some refreshments will be served in the, it's called the King George, where you came in this morning, and breakfast, tea and coffee. But before I let you all go, can you just indulge me for a second? Bertie, can I put the house lights up and get a photo of everyone, please? If you don't want to be in a photo, please cease to exist briefly. Thank you. Thank you very much. Right, yeah, food now. Next talk start at 10 o'clock. Thank you.
depression, guilt, shame, and other unwanted emotions. Within love, you'll find creativity, freedom, trust, hope, and thankfulness. Moment to moment, listen to your spirit, the quiet, still.
Collective and not the culture, no. Capsule collection, no culture vulture, no. This is for the love and all my mankind. For like beings and not like minds, who'll take their time to read between the lines, decipher the lies in the disguise. Green tea sensei, open your eyes. This is for the love and this is for the sky. For Krishna and Jah, for Atom's eye. This is for my brother and my sister. For my dad up high, yo, you know I miss ya. This is for my JIGs and all the devotees on the front line, keeping it holy. On the front line, keeping it holy. This is for the youth that can't be silenced, not battered, not beaten, no, you try to find us. This is for your heart and not your mind, no man-made constructs, no divide. This is for your spirit, for your loudest voice, for our right to party, this is our noise. We were sung into creation, we have no choice but to chant out loud down Babylon, rejoice. Make noise, make noise, make noise. Make noise, make noise. Make noise, make noise, make noise. Make noise. earbud near you. This sound, this sound, this sound, this sound, this sound is physical. It's very physical, but metaphysical and mystical. And no, we're not in your peripheral, but find it difficult to minuscule. This sound is physical. It's very physical and literal, but metaphysical and mystical. And no, we're not in your peripheral, but find it difficult to minuscule. This sound, this sound, this sound, this sound, this sound is physical. It's very physical, This sound is sensual and plentiful, alchemical. It's medicine and medical, like medicine. Now open wide and let it in. This sound is sensual and plentiful, alchemical. It's medical, like medicine. It's medicine. Now open wide and let it in. This sound. Must be some medicine. You know your soul needed it from the very beginning. And now you're loosening it. You hear the truth in it. Your little toes telling you got to move to it and groove to it. It's a groove to it. You got to groove to it. This sound. This sound. This sound. This sound. This sound. Physical. It's very physical and literal. Metaphysical and mystical. I know you're not in our peripheral, but find it difficult to miss you. This sound is sensual. This for my people, yeah. Free all my people, yeah. All my people, yeah. This for my people, yeah. Free all my people, yeah. Free all my people, yeah. We don't wanna chat until my people free. We don't wanna chat until my people free. We don't wanna chat until my people free. And we are gonna chat until my people free.
You'll be famous for the wrong thing. Gossiping and fronting is a long thing. All that other nonsense is just fussing. And it's like living in a contest. Can you free us from this concept? Free us from the chains that you all invest. Government indulging in some incest. Ignoring all my people in a protest.
It's for my people, free all my people, all my people. It's for my people, free all my people, free all my people. We don't want to chat until our people free. Release all of my brothers on a we church, please. You don't get to tax me on what God gave me. Paying for hypnosis off the TV screen. No. No. So much confusion onto my people. All disillusion falling my people. And disillusion poisons my people. Suppress my people. Oppress my people. No. Free up your mind, you know your soul's divine. They can't take your spirit or they steal our time. Man-made constructs created to divide. You can't hold us down with systems you can try, but no.
We don't wanna chat until my people free. We don't wanna chat until my people free. We don't wanna chat until my people free. And we are gonna chat until my people free.
Sang family, doing it properly. my shit. It's gotta be profound. Staying underground. Colonies my noun. Wear your dirty crown. See Babylon is coming down. We gotta feed the minds for the correct sound. Yeah. I gotta be careful when my thoughts down. They're very powerful. I found out it's not a joke thing. When you give time, it's all energy. You gotta free your mind from their confines, conditioning. Our whole tribe with misspelling and division and conquering of holy lands. We gotta be conscious with our words now. They're very powerful. I found out it's not a joke thing. What you say loud. And now our shit, it's gotta be profound. No, it ain't the same being a man today. No, it ain't the same. No, it ain't the same being a man today. No, it ain't the same. Waking up to this disarray. This uncertainness only seems to serve the misery. May a place on me, mother, take from me all of this bullshit. I do not need it. I believe in magic because I've seen it. Nothing you, the ego, you know already how it goes. I got a strong man, strong girl for my head to get going. I let go of desires, but I truly let go of the fires that burn them and fuel them. It's so hard to be human with a battle in mind. I have lost all devotion over time. I'm on a path of remembrance, and I'm remembering fine. Having nothing that's mine, only borrowing time, my kind. Chatting to God, unworthy of his time. With all these doubts in my mind, trying to cast aside. Left to struggle in my right. No, it ain't the same being a man today. No, it ain't the same. No, it ain't the same. Being a man today. No, it ain't the same. No, it ain't the same. Being a man today. In a battles dwell like city kids beneath the poverty line. I'm feeding my senses. Food for thought is money well spent it. Cause most of our so-called knowledge is rented, invented, depends on flippant frenzies. Social scenarios, holler like Cheerios, you hear me though? Never thought I'd be coming out your stereo, but there we go. From Activia, it's retained now. Now it ain't the same being a man today. No, it ain't the same. No, it ain't the same being a man today. No, it ain't the same being a man today. No, it ain't the same being a man today. No, it ain't the same. No, it ain't the same. I've got some knowledge, but I am not learning. With an earthy mind drags me back to surface. My Hare Krishna boys tell me it's about service. But if my mind binds me here and my words to God earnest, my words to God earnest. I've got some knowledge, but I am not learning.
Okay, good morning, everyone. I hope you've all enjoyed the keynote earlier and managed to get a quick refreshment break. I just wanted to introduce you to Derek, who's our first speaker for the Portaton track, and then there's a room change at 11 o'clock. So without further ado, Derek.
Hello, good morning. I can hear you, I cannot see you whatsoever. So if you have questions, I don't know what to do about it. So I guess we'll have to take those at the end when they can put up the lights again. So when you have one, try to write it down or remember it. Hello, good morning, I'm Derek. I'm living in London for a long time. I used to be the PHP 7.4 release manager, but PHP 7.4 is no longer supported, and neither is PHP 7 itself. So if you're not in PHP 8 yet, you have some work to do in the next few weeks. I'm employed by the PHP Foundation to work on the language itself, and that's kind of interesting. If you have any suggestions for the language, come and find me later. I'll be around for the next few days. I've also developed the debugging extension Xdebug that you might be aware of. If not, again, please go look for this. And I like maps, beer, and whiskey, but that has nothing to do with this talk. If you have any further questions, you can try to reach out on Twitter, but preferably through Mastodon or the Fediverse, because that's what I've been switching to, and I think some other speakers as well here. But let's dive straight into PHP. Now, although the title of the talk is What's New in PHP 8.1 and 8.2, I honestly can't always remember in which PHP versions things have been introduced, so take that with a small approximation. I would say that everything you see in the slides will be available in the latest version of PHP, which is 8.2. But I'd like to go back a little bit further, mostly to see sort of a progression that PHP has been on in the last, well, half decade or 5 years or something like that. Now, I've been writing PHP for a long, long time, and sometimes we had like classes, like a number class, right? I mean, this is a trivial example. They're usually more complicated, such as money or stuff like that, where we want to store a number, and if you want to store that both as an integer or floating point number, you never could, right? The only way how you could do that is by documenting it and hoping your ID tells you if you do things wrong. But of course, this is not great. So PHP started introducing these union types in, I believe, PHP 8.0. So now you can type your properties as well as your arguments and your return types with two different types. Those are the union types, which of course makes it a lot easier. Now, the reason why these were originally introduced into PHP wasn't necessarily so that people using the language could make use of them, but they were introduced sort of as a side effect of changes in PHP itself. With PHP 8.0, we started introducing the JIT engine, a just-in-time compiler to make your PHP code basically run as normal computer-compiled code on your CPUs. Sort of. Not quite, but sort of. And the intention with that was that, well, we get to, if we add more specific types to internal functions, this engine can make use of this information and generate better code that then runs faster again on your systems. But PHP has some interesting internal functions, such as microtime, right? And by giving it an argument, it returns a different type. Like if you don't give it any argument or false, then it will return a string, where you have the fractional seconds, the space, and then the seconds, if you might remember it. Or you give it the Boolean true argument, and then it will turn a returning floating point number. And those are actually sort of union types, but they were never possible to type in the language, where we could only do either string or float. So one of the reasons for why we added those union types was then to make sure that we could type this in the language itself, and then the JIT engine could make use of this. Well, that was theory, that never happened, but the side effect is that we now have those union types, and of course, if you can use them in engine-specific code, then it also makes sense to expose this to userland, the language that you use to write PHP code. There's lots of rules around union types. I'm not going to mention all of the things on the slides, but there's always restrictions to what you can do with these union types, and some of these have now been lifted actually. Like void can't be part of a union type. Like it makes no sense for a function to hint that it can return something at the same thing that it can't return something. That makes no sense, right? Pretty much everything that you expect to be logically correct is what union types will allow you to do. With the exception, for example, is that you can't do redundant types. You can't do bool or false. That makes no sense, right? Because if it's a boolean or false, then it's redundant. False is already included in boolean. Or you can't do object or whiskey, for example. Or parent class and inherited class. These things make no sense. The order in which you define them also makes no difference whatsoever, and we have this specific case, or we added the specific case that array or traversable is the same as iterable. Now, we've switched that around. If you want to know more about how this type system works, George Peter Banyard gives a talk about it, I don't know when, but later in the conference, where he dives into great detail on how this specific typing works, and also some of the other typing that I'll be showing you a little bit later. Now, we started adding some more strictness to the language in a way that it's easier for you to express how code should behave without having to work around these things, right? I mean, the way how people wrote read-only properties was usually by having a private property. The syntax that I'm using here in construct, if you have not seen that, is like a constructor promoted properties. So if you use like the visibility keyword in the argument list for your constructor, they will actually be turned into private property string name. I have a better slide of that in a moment. And then, yeah, you have the getters to exit information, which means that outside of the class, of course, you can't ever write to name property. But that's a bit of a kludge, and you have to implement getters to get to the data from outside of the class. So P81 gets a real keyword, read-only, that enforces that for you. Now, read-only is a little bit tricky because it really should mean write once. Because, of course, at some point, you do need to write a value to the property, right? Otherwise, it's like always going to be null, which is kind of pointless. So the rules for this is can only be initialized once in a constructor preferably, but doesn't have to be the case. Or it can only be initialized from the scope where it was declared, meaning you can't do it outside of the class whatsoever. You can initialize them in factory methods that construct the object that you are then defining this read-only property on. Which is kind of nice. You can't have read-only properties on static properties and not on untyped properties. The reason why you can't have them on untyped properties is because the way how the engine works, there's just no way of attaching that kind of information, so it is just not allowed in that case. Which I don't think is a real problem, to be honest. Now, of course, sometimes you get classes that only exist out of read-only properties. And in PHP 8.1, you had to specify all of these properties as read-only. From PHP 8.2, you don't have to do that anymore. You can match a whole class as read-only, meaning that all the properties that are defined in it, either through constructor property promotion or defined by hand by yourself, are all defined as read-only now, by default. Now, that does mean that these read-only classes can't have any static properties or untyped properties, because these can't be marked read-only. It also stops it from allowing dynamic properties to be created. Dynamic properties in PHP is basically if you do this and then the property name of a property that hasn't been declared yet, it will just create it on the fly, right? PHP has been doing that for a long, long time. You can't do that with read-only properties. With read-only classes, because then, of course, that property that you then assign a value to is not a read-only property, meaning that you don't have a read-only class anymore. Now, we got some interesting union types introduced. We have mix, which is this whole long list that I won't read out. The introduction of mix is kind of, why would you want to type something that can be everything, right? It's kind of pointless. But that's not really quite true, because it allows you to distinguish between the cases like, I haven't looked at this code yet and all the types where I needed to improve my code to, well, you don't need the types, but it makes it easy to see what's going to happen, or it really accepts any value in this method or return type or property. If you don't define a missing return type, or if you don't define a return type, then the declaration is always going to be mixed or void. I think this is kind of a useful way where you have a specific generic class. Don't talk to me about generics. Maybe later. It's like a generic class where you store things of multiple different things without you having to do anything about it. So mix is kind of useful there. Now, to come back to the constructor property promotion, the reason why we added that is because more and more people started to use things like data value objects. In this case, I have my whiskey class. Yes, I like using emojis in my class names. I would not recommend you do that because it's kind of hard to type, but it's fun. My most annoying trick is to use a non-breaking space in your class name, so it looks like you have a space in your class name. Right, anyway, again, also don't do that. I'm getting sidetracked here. What constructor property promotion is about is basically, if you have a property defined in your class, if you want to assign them in your constructor, you have to write out the type 2 times, the name of the property 3 times, and yeah, you have to just so much boiler code, right? And so much of my code looked like this, and other people's code, I'm sure as well. This is annoying to have to do. So with constructor property promotion, as I mentioned earlier, you can move the visibility keywords into the constructor parameter declaration, and then you end up with something like this, which is a whole lot easier to do. And also what we added in PHP 8.1 is like the trailer comma here in parameter declarations. It's like this nice little thing that you don't really notice, but it's actually really useful if you want to add more properties to things like these value classes. Now, in my whiskey application that I used to record all my whiskey notes, I have a bunch of things in there that sometimes I want to search for all of the stuff, for all of the notes that I've made, and depending on which situation I am in, I want to include information about the distillery or the description or the notes, or how many items I show up on the page and by which field to sort them, right? And you end up at like sort of a search settings class like this. Now, when I instantiate these things, if I see this in the code, new settings, true, false, when reading that line of code, I have no idea what these true and false keywords actually mean, right? In this case, what I want to do is show everything as normal, but not include the descriptions. But you can't see that from this line of code. Similarly, if I want to just change the sort order, what I have to do is I have to know which position that is in my argument list, and also what the default values of all the other arguments are. It's a very annoying thing to have to do. So what we introduced is named arguments. So named arguments is basically a way of specifying the argument not by position number, but by name. So for example, if I want to not show the descriptions, but everything else keep default, what I can do is just include description : false, and that's it. So I also, from the description for this line of code, I can immediately see what I'm actually intending to do here, as well as not having, in the other case, having to specify all the other default return types, or sorry, default values. Now, I think named arguments for this kind of situations are a good thing to have, but I think you need to be quite careful about where you would use these. Especially because if you can now refer to arguments by name, that also means that the names of these arguments are part of your public API. So if you have a library, for example, and that includes what PHP used to have, sometimes a datetime string was date_string, and sometimes just string, and in other cases was datetime. I mean, it was quite a bit of a mess. And if your API has never been designed to also have your names of your arguments to be consistent or among your own code base, then you're not going to have a good time. What we did for all internal PHP functions, we went through all 3,000 plus of them and made sure all these names were consistent, at least among the same extensions. So all the MySQL stuff would have the same names for the same arguments that would mean the same thing. But it also means that if you now publish a library, then users could use argument names by calling methods in your library, for example. But that also means that then you can't change those argument names anymore. And of course, for a library, a public library, you then have to make the decision whether you would consider these argument names part of your API or not. I mean, if you don't, then some of your users interacting with the library might run into problems if they refer to the arguments by name or not. So I think the only real use case for named arguments is either among your own code base or when you have things like this. But I would always be very wary of using that by referring to methods of a library that you have no control of, like things you find on packages through Composer, for example. Now, we got some more types. As you have noticed, everything is about more types in PHP. Not only, but many things. And an enumeration is a nice way of describing a data type that can only have a specific set of values. I'm taking a very small example here with currency. In my case, my enumeration can have two values. It can either be GBP for the Great British Pound or EUR for the euro. Other currencies are available. And you can now type against these things. So the definition of enumeration is basically like this. You have enum type name, internally implemented as a class-ish, sort of. It's complicated. And then you have the two values, which are GBP and EUR, which you specify by using the case keyword. In this example, there are no values associated with anything. It is just the name GBP and EUR are your enumeration values. And the way how you can make use of this is, for example, in your constructor argument in this case, I use private currency, and currency looks like a class name, but it's the class name of an enumeration in this case. And then when you call the constructor with new product here, you specify the enumeration value by using the double colon on currency. So I say currency colon colon EUR to specify the euro. Now what you can, and then you can get a result if you var dump this. It looks something like this. So PHP will know what to do with this enumeration and show you a reasonable value here. Now, these enumerations are types, right? So this type can have two values, GBP and EUR, which means that it would also enforce types against that, of course. So what you can't do is then specify as a string EUR, because that is not either currency GBP or currency EUR, and then you'll get your type error because it doesn't fit your type. Hopefully that's what you expect. That's the whole point of having them in the first place, of course. Enumerations can have backed values, either a string or an integer, and those are the only two options at the moment. And you specify that by using colon and then a type name after the enumeration definition. And then each of the cases you can assign either a value to. Either it has to be either all strings or either all integers. This is called a backed value. In the normal cases, like the slide is the rest is the same. But when you do a var dump, you of course also see the value. But you can of course do useful things with these values. For example, you can access the backed value by using the value property on the enumeration. This isn't something that you have to define yourself. The enumerations are quite a lot of magic things under the hood. They also define some methods I will show you in a moment. But you can access the value here. You can also create an enumeration typed value from a backed value. So if you give the string, in this case the pound sign or the euro sign, you will then get the enumeration value back that matches this backed value. What happens if you give it a string, in this case, that isn't matched with a backed value, you'll get an error because you can't do that. Now, which means that if you want to do it from any random source, there is the try from method, static method. So if you give that a backed value that doesn't match any of the values in the enumeration, you'll get null back, otherwise you get the enumeration type back. So it's kind of a magic function attached to enumerations. Enumerations, they're classes, so that means you can also have functions defined on them. And in this case, I have the function format. You give it a number, and depending on the currency, it will format the number in either with the currency sign first or last. It's a trivial example. I'm sure you can come up with more useful things than this, but For example, the output is this. If I create the enumeration value currency, GBP, and then I call format 42.75 on it, you get the pound sign and then 42.75 because we're matching here against GBP. Now, match is also a new keyword. It acts like a switch-ish. Instead of having to use case for each of the cases, you basically get a list of statements on the left-hand side, arrow statement on the right-hand side. The one on the right here, the currency GBP, is what you usually would expect to be the value in case. And then the statement on the right is not only the code that is being run, it is what is being returned from match. So basically those 4 lines say that if we match this, if it's GBP, then we assign this value %.2f to pattern as a return. So at the moment you can only have one statement in there, but that statement could be a function call, of course. What it would also do is that if match finds something that it doesn't have a case for on the left-hand side, you get an error telling you that we found a value that there was nothing matched against. The default keyword still exists, so you can still use that as well, but my slides didn't fit on my slides, to be honest. And then, of course, because the return value assigns to a variable, you can then do something with that variable in a future version, future function call. You can also have static methods. They're mostly useful for as in in factory methods. So if we give it a locale, it will then return the value, the currency in this case, that belongs to this locale. I have made up locales. UK GB makes no sense because that's Ukrainian in Great Britain. I'm sure some people speak Ukrainian here, but it should be GB_EN really, I believe. I can never remember those locale names. And then, yeah, you can, as I said, you can use those as alternative constructor. There's also a method for listing all the values by using cases, not very interesting. Or you can do this. Sometimes you want to make a list of, in this case, we have constants. We have an array where we have on the left-hand side, we want to have an enumeration value, but on the right-hand side, assign a value with it, right? It's just like an array definition in this case. But you can't do this because on the left-hand side, the constant expression isn't really constant as much, because in arrays, your keys can only really be integers and strings, and an enumeration value is neither an integer or a string, even if they're backed by them. So the way how to get around this is in PHP 8.2, you can access the value property on enumerations in this kind of situation. We originally intended to be able to access any property like this on any class, but we really didn't find a use case for that. There was also a ton of edge cases that were really hard to find out, so at the moment we restricted this to only properties on enumerations. And the only useful one here is then value, if you want to do that. Some more fun types, we added the never type, which isn't really a type as such, it's more of a declaration that a function never returns. And if your function would end up returning because of a logic failure, then you'd get an error from the PHP engine. So the never keyword is something you define on methods that never return, like if they always throw, for example, or if there's an exit statement in there, or a die, or things like that. It is kind of useful in functions where you set up a redirection, you set a header, and then you want to enforce that no code gets run after this. That's where never comes into play. Similarly, if you have a method that calls another method that you know is never going to return, you can also define that on this kind of implicit methods as well. This keyword was mostly added for like static analysis tools to be able to reason better about how code can act. I have to admit I've never used this in any code myself before. Whether I will, I don't know yet. We'll find out at some point. Now, things are getting more complicated with types. And I'm going to try this in a sort of way. I mentioned that in PHP 8.0 we introduced union types. But sometimes you need to enforce that a parameter that you pass in is both traversable and countable, if you want to for each over those, for example. And traversable and countable on their own can't do that. So you need to sort of come up with a way of enforcing that there are both interfaces are implemented. And there were hacks around this. Again, please don't use this in production code. The way how this works is that we create two properties, traversable and countable, and are typed with traversable and countable. And then we have a private property both, which would be the name of what that property would be. And what we do in a constructor is that we sign a reference to both traversable and countable. Meaning that whenever you want to set both, because they link to both traversable and countable, you end up having to implement both interfaces, otherwise you can't run this code. Which means that if you try to sign a countable iterator variable that isn't both of them, you'll get a type error on one of these assignments. Now, this is an ugly hack. Please don't ever use this. Instead, use PHP 8.1 where you can actually type these correctly. So these are called pure intersection types. With the word pure actually means here that you can only do intersections. You can't combine them with a union as well. And basically what this means is that the arguments or the properties or the return values needs to implement both interfaces, or mostly both interfaces, I would say. You can only use this for class names and trait names and interface names. You can't use scalar types like a string and int, because nothing can be both a string and an integer at the same time. It's pointless, so we just don't allow you to write code that could never technically work. So these pure intersection types, the only actual use case I've found for that is actually traversable and countable. I'm sure somebody else has other ideas as well. All right, some other cool things that we have. We go back to some other syntax. So in PHP 7.4, what we added is the ... operator that basically includes all the elements of the array that's being referred to into this location. So the return of this would be the fruit salad, that is a pear, a peach, and then a red and a green apples inserted from the first apples array, and then you get a strawberry and a tomato. Although these are all fruits, I don't think having a tomato in a fruit salad is a particularly good idea. But botanists will disagree, I suppose. Now, because we have, the main reason why we have this sort of insertion was often when you do things like call user func and stuff like that. But with PHP 8.1, we're getting now named arguments, right? So there had to be a way of introducing a list of named arguments also into other arrays, which is where the support for string keys in these arrays, in the ... operating arrays, now comes into use. So what I have here is I have two arrays. One is apples, one is others, and then we create the array fruits by introducing all the array elements from apples. So that means we end up with having red apple and green apple. And then after that, we're adding all the elements from others with the keys, right? So we have green pear, and because this key is the same name, it would overwrite the original one. And this is really useful if you have, for example, set of option classes where you have a set of defaults, and you want to overwrite them with something that's being passed in or defined by a user of your code or of your library or something like that. Which means that, in this case, apples would be your set of default values, and then anything and others would basically replace the default values in there. It is sort of the same semantics as I believe you get with the plus operator in between arrays, but then with syntax sugar with the ... operator. I think this is kind of useful, and this is actually something I have used in my libraries because of the case where I had a set of default options and I wanted to override them with something new and different. Now, fibers is something that got introduced in PHP 8.1, and this topic alone, I can't, people can talk an hour and a half about because it's quite a complicated way of doing it. So I don't have the time in this slot to do that. But the idea behind this is that this is sort of cooperative multitasking. There are a way of separating out your code and waiting for I/O at the moment so that it doesn't block your other code from running. That's sort of the easy way of explaining it. what it boils down to is basically that you can have code running in these fibers. Go calls them coroutines, for example. They are a way of separating out chunks of code, and they make a lot of sense if you have to wait for I/O, slow I/O. So it is a way of, or what you could do is you could start downloads in 16 different threads, I mean fibers. And then they can pull in data when data comes available on the network, instead of having to download the first file first, and then the second file, and then a third file, and things like that. And when one of those fibers is then waiting for I/O, they can say suspend, and then there's then a way of unsuspending those when data comes available on the socket that they're trying to read from. So this is a way of cooperative multitasking. No code runs at the same time. They all still run in order, but it can then run when other bits of code are waiting for I/O to happen. If any of you are familiar with Windows 3.1, this is how Windows 3.1 implemented multitasking in its operating system. Luckily, we don't live on those times anymore, and we have now, of course, operating systems, including all the versions of Windows and Unix, where the operating system interrupts the tasks. But that is not what fibers are, or what Windows 3.11 is. There's no logic that interrupt fibers, or in Windows 3.1 case, programs at any random interval. That is not how this works. I don't know whether there's a talk about fibers available on this conference. If you're interested in, I'm sure there's quite a few recorded and findable on the internet. To get back to some of the slightly more boring syntax additions to PHP, sometimes we add things because they're necessary for functionality, and sometimes we add things to make it look better. And in this case, both. Now, you might be aware of that in PHP you can refer to a method or a function by specifying an array with the object variable in it and the method name. These are also the callable type. Now the callable type is kind of useful, but not in this kind of situations. See, I have this test class, right? And I want to get a reference to a private method from that I then can call later by just using this reference. Now before PHP 8.1, I would say the only way how you could do it is by doing as two array elements, this and private method. But what would happen if you tried to call this, you'd actually get an error, because the moment where this is called, this is now no longer the same object, and the scope wouldn't allow you to call a private method, right? Calling private method here is basically just a shortcut for calling this private method. And you can't call that because it's a private method. So what we introduce first is closure from callable. It's a way of, at that moment, binding this already to the closure that is being returned. And because the scope is then bound, you can then call the method, because the private method is called in the scope of the closure, which is bound to this. So that would be okay, and you could call the private method. But having to type closure : from callable and then your object's variable and then your method name is cumbersome. So what we introduce is another version of the ... operator as the sole thing in between the parentheses that you call to any method or function. This basically does exactly the same thing as closure from callable, but in a nicer way. And you can do this on basically anything that you would expect it to do. So it isn't actually new functionality. It is functionality that just makes it easier to use already existing functionality. Something we call syntactic sugar. It makes it nice and sweet and sparkly, I suppose. You can do this for everything. I mean, there's more versions, but they didn't fit on the slide, to refer to any method as this. The intention at some point is to extend this to not only requiring a reference to a function, but also already to fill in some default values. These are called, I've heard different names, but partial applicable functions is one of those terms I've been hearing about, which is basically a nice way of being able to chain these kind of references to methods, with information all pre-filled in. It is something that functional programming uses a lot. And we have some fans of functional cell programming in the PHP developer community. And so might see some more work on that in the future. Whether that comes in PHP 8.3 or not, we'll have to see. Probably not, actually. Now, PHP 8.2 also introduced some new types. So the null and false types that we added in PHP 8.0 to be part of unions weren't allowed to be used standalone. So you couldn't type a return type as just false. It had to be string or false. And similarly, null or false, you couldn't do either. You had to use null or bool and things like that. You also couldn't use null standalone, which means that if you had a class like this, you have like a user finder that returns either a user, if it finds one by email address, or null, if it doesn't find anything. If you wanted to have like a test class or a null implementation of this user finder for using somewhere, you couldn't actually type in that with null, even though that logically should have been allowed. But PHP 8.2 now allows that, so you can type things against null and false, which is kind of useful. We also didn't have a true type. We only had false and null, but not true. So we decided to make the language a little bit more consistent and also now allow true in the same situations where you have false. Now, it doesn't necessarily, of course, make a lot of sense to type arguments to functions or return types as true or false, because a method that always returns the same thing is usually kind of pointless. Because why would you return anything or accept any argument in the first place? But sometimes when you're refactoring code, you figure out that, take for example the microtime function in PHP. If in PHP 9, for example, we would only allow it being returned as a floating point number, which means we can only accept true as arguments, we could change the type hint from bool, what it currently is, to true, so then enforce it when you call microtime, to make sure that you always get the same floating point return type back. Of course, that is a backward breaking change, and we are not considering doing that for microtime, but that would be a situation where it would make sense to type in against the values false and true. One other thing I have to say about false and true, if you are writing code where you don't have strict types enabled in your file, then if you would define a type as bool, then PHP would coerce any data into bool, so either turning it into true or false. But if you type it against false or true, and the value that you're passing in isn't false or true, you'll get a type error. It doesn't then coerce to false or true, because again, that makes little sense to do. All right, so in PHP 8.0 we got union types, right? Int or float. In PHP 8.1 we got the intersection types, where you have, or pure intersection type, where you have the end. Both of these things have to be true at the same time. And in PHP 8.2 we introduced DNF types, or disjunctive normal form types. You can guess why we call them DNF types, because it's a lot easier to pronounce. Which basically allows you to define types as a union of intersections. It doesn't allow you to do an intersection of unions. There's also no need for that, because it can always be rewritten. Again, if you're interested in how all this stuff works, George has a much more in-depth talk on that later in the conference. The only use case that I've seen people use it for so far is to create a union between array or traversable and countable. Again, for each cases in some case. So you can then accept both an object that implements traversable and countable, or an array, because in an array you can also for each over, of course. Yes, although my syntax doesn't quite look the same, because array isn't an intersection of two different types, it's an intersection of just itself, but that's still an intersection. So you can do single type or intersection or set of intersections. Again, I haven't seen all the use cases for it yet, but I'm sure they exist. We also get a new random extension, which is my favorite slide, because every time I reload it, it shows something else. It's a nice way, a nice API to create random data in a mostly safe way. Now, of course, it isn't true random, it's still a pseudo-random engine, but multiple engines are implemented. Some of them are a bit slower, some of them are default, some of them have ridiculously complicated names, so I will not try to pronounce the first line of this code. Most of them you can give a seed value, which is useful if you want to reproduce the same random values. I mean, that might sound weird, but there's use cases for doing that. You do that by specifying in this case, a integer. I've commented it out. Otherwise, if I refresh the slide, I'd always get the same result. On this randomizer object, you can then things called get bytes to just get a random section of bytes. In this case, I want 8 bytes. If I would show them directly, it would gargle up my screen. So I'm converting them from binary numbers to hexadecimal. Similarly, you can get an integer in a specific range, or just get the next integer out of the randomizer engine. But also things that are kind of useful are picking a set of keys out of an array. There's been several cases where I would have found that useful. I mean, you can sort of emulate it by using array shuffle and array, I think it was called array swap. It's the one that swaps values and keys and stuff like that. So it is implementable, but it was never done in a nice way. And it also wasn't as correctly random as this random extension does it. So you can do pick arrays, and then you get 2 arrays keys out of it. Similarly, I have to make the slide once smaller. You can also do shuffle array, which shuffles the array in a determinate but random way, whereas array shuffle in PHP, again, was a bit shaky. And also it allows you to do shuffle bytes, which is useful if you have a string that you want to scramble. As you can see the bottom of my screen, it changes to different fruit salads, and different order of the letters in PHP is great. I think it is kind of useful to have this kind of APIs in PHP because they are a great way of making sure that you do things correctly. Just like we introduced a password set of functions, like the password hash functions. These are always a set and good way of doing this, and much better than trying to come with your own randomization or random ways of creating a set of things out of an array, for example. So please use these if you can, instead of hand-rolling things. Now, you might remember that I mentioned dynamic properties when I was talking about read-only classes, where you couldn't have, where a read-only class, you can't create new properties that haven't been declared yet. We actually started deprecating these altogether in PHP. So PHP 8.2 now throws a deprecation notice if you try to write to a property that you haven't defined yet. I was the only one that voted against that. And I now disagree with that, by the way. Yeah, I know, I'm disagreeing with myself. Because funnily enough, I was later upgrading some code to run it on PHP 8.2. And my tests started throwing deprecation warnings because one of my fellow library authors had spelled palette differently twice. I mean, they're both English words, but they mean something very different, right? So this was showing in my test the following deprecation warning. It says the creation of dynamic property palette is deprecated because we declared it as palette instead of palette. Of course, I had to now fix this code. So I actually found this useful because in the cases where you have it protected, it makes not so much sense, maybe. But if you have a typed property that you then misspell, then it doesn't enforce the types anymore, right? So I think this is now useful. And if I could change my vote, I would. But also, it wasn't important enough to do that. So I had to make a quick patch to my code. I have since then had to create many more of these in other bits of code. Now, of course, there are some situations where these dynamic properties actually do make sense. Hydration from a database table, for example. And there are 2 ways around the deprecation warning. You can either make your class extend from std class. So std class, of course, is a object in PHP that you can't declare types properties on at all because it's implemented in an engine. So you can still always use std class and define dynamic properties of that. Or there is a attribute that you can set on a class, which is called allow dynamic properties, and then you also won't get the deprecation warning. Now, at the moment, this is a deprecation warning that is basically a way of telling the users of the PHP language, that this is functionality that is going to go away in the future. We don't remove these things until the next major version of PHP, which would be 9. When PHP 9 comes out, we don't know yet. I mean, it's very likely that the next version is going to be PHP 8.3. We only really bump the major versions if we actually end up breaking things or introducing a new big shiny thing, such as a JIT engine or a vastly improved engine that we did in PHP 7. So deprecations are a way of the PHP developers telling you, you're going to have to look and pay attention to this because it's going to go away in the future. It doesn't necessarily mean that the moment you see deprecation warning, your library is broken that you're using, and it's also not a reason of pushing or suggesting to library maintainers that they need to go fix their code, because it isn't technically broken. Unfortunately, lots of people in either their error handlers upskill even deprecation warnings to exceptions and errors, but that is not the right way of dealing with these deprecation warnings, because it's just a hint to developers that something is going to change. PHP Unit also used to do this. It would consider deprecation the same as a notice, a warning, and promote those to exceptions and failure tests. PHP Unit does not do that anymore and hasn't done for quite some time, because, as I said, deprecations isn't something about stuff that is wrong now, but it's something that is going to go away in PHP in the future. All right, and the last thing I want to show you is sensitive parameters. This was proposed by a person that works for a company that has a bit of software that their customers install on their own machines. Don't exactly remember what sort of product it was, but administrators of the software run by these third-party clients of them, they had a forum and they would share problems in there, and sometimes they would share stack dumps. But these stack dumps often included their AWS keys or their usernames and passwords to the databases. And of course, that isn't something you want to share with the rest of the world. So he came up with this idea of, well, maybe it might be nice to specify that specific arguments are sensitive. And if you add this sensitive parameter attribute to these arguments, then it will not show up in stack traces. So that's what happens now. So in this case, because we have marked password as a sensitive parameter, if you get a stack trace for whatever reason, in this case I'm just throwing an exception, then in the stack trace, you will see that it's been converted to an object of sensitive parameter value, and it doesn't show you the value. If you use getDebug backtrace, the value would also be replaced by an object of sensitive parameter value without you being able to see the value directly. However, you can still access the value by, I believe, the value property, or the getValue method, one of them. So this is a way of preventing these things when they get converted to strings from showing up in screens or log files. That's the intention here. Now, if you have XDebug loaded, it doesn't actually convert it to a object, because it doesn't have to, because XDebug would only create strings out of it. It doesn't have this getDebug backtrace functionality, because that's part of PHP. So I do it in a slightly simpler way in XDebug by showing the value as the string sensitive parameter, because I don't need to do more than that. Now, that does not mean that if you're debugging this in a debugger, that your values get replaced by sensitive parameter. It's only something that happens if you're converting anything to a string, like in a stack trace, like I'm doing here. I think this is kind of neat to have. So not only can you use this parameter, this attribute for code that you write yourself, it is also, we have gone through the PHP source code, and every time when we have either a username or a hash value or a password possibility, we've also internally added this sensitive parameter attribute. So anything for internal functions like MySQL Connect and things like that will also only show up as sensitive parameter in your stack traces, which I think is a nice, safe way of doing things. All right, that's about what I had to talk to you about PHP 8.1 and 8.2. About 8.3, I can't say very much because not very many things have been accepted. I reckon that will change in another month or two once we get closer and closer to feature freeze in July somewhere. So yeah, hopefully this was useful. I certainly didn't cover all the chains in A1 and A2 because there are so many more in these. If you have any questions, I am happy to spend some time answering them. Otherwise,
Derek.
thank you very much.
So I neglected to mention at the start, those of you who have joined on Discord, feel free to ask questions in the channel. There's a Portaton channel if you'd prefer not to be handed a microphone. I think it's important everyone has a voice. Are there any questions for Derek at all?
There are questions, but
So
I can't.
I will run over with a microphone.
Can we change something with the light so I can see the audience? That'd be nice. Magic will happen, hopefully.
Hi, Derek.
Hi.
Regarding the randomizer, you mentioned one.
Can you hold the mic a bit closer?
Regarding the randomizer, you mentioned one randomizer engine there.
Yeah.
How many are there, and is there a cryptographically secure one?
I think there are 3 at the moment. There's your standard Mersenne twister, the one I showed, and there's another one that I can't remember what it is now. The reason why there's different engines is that other languages implement also these engines. So if you want to match random numbers with the same in different languages, you can then generate the same values, which is useful if you, I can imagine it'd be useful if you're doing things like two-factor authentication where you have a seed number on each side and you have to generate the same random numbers in different languages. So that's why these engines make sense that there are different implementations of them. All right. Anything else?
Any other questions?
No questions? That works for me.
I have a question.
Yeah, go for it.
Which is your favorite feature and why?
My favorite feature? Oh, yeah, I don't know. I think it's more of a progression of things, like the progression of being able to add more types, being more expressive with what you write in your code without having to resort to hex or documentation. Because, of course, adding these types to things isn't only useful for you, it's also useful for all the tools that you're using, because they can also use that to infer things and suggest on how to make your code better. Both IDEs do that, as well as the static analysis tools like Psalm and PHP Stand, for example. So I think it's more the progression than specific features in the language.
Brilliant. Thank you very much.
Thank you
Derek.
very much. The slides will be up there later as well.
There we go.
And I'll pop into Discord later as well. I haven't done so yet. But oh, there's another one there. Sorry. It's hard for me to see anything. I just blank wall here.
Do you think we'll get something like structural type aliases or type defs in C terminology?
That's a good question. Because our types are getting more complicated now, we sometimes here say, well, I don't like to have to type array or traversable and countable all the time. And a common way for doing that is creating type aliases so that you don't have to do that again. So yeah, this is something that we're looking at doing, but it is kind of making the type aliases themselves isn't the hard bit. The hard bit is where do you define them and how do you scope them. So in PHP, every class tends to end up in the same file. And because these types are sort of classes, one of the logical conclusions could be that, well, these type definitions, because they're own classes, they have to be in their own file, which means they would be able to use just and auto-load it on the fly, for example. But that's kind of annoying to have lots of files that only have the type definitions in there, right? The other alternative is that we set these type definitions in just the files where they are being declared in, because that's how PHP usually works. Every single file is seen as its own unit, and it doesn't share anything with other files. That's, I think, quite a good way of design of the language itself is. But that means that if you have a type alias, you'd have to copy the type alias to every file or every class where you then make use of the type alias. Because of these things, we haven't quite come up with either solution or a better solution in that yet. So that's why we don't have them yet. But it is on our list to want to add to the language. Maybe PHP 8.3. We'll see. Yep.
Any other questions? Any of you have just joined Discord? I've just approved you if you wanted to ask. Because there was a flood of 5 that just joined, so Okay, another one
All right.
on the microphone.
I didn't see that, but
Yes, we do have 4 minutes to fill for any other questions. It's always good to get questions.
Is there any performance benefits of using, actually that question I wanted to ask about read-only, but if there's anything else that you think that could contribute to performance, which one would you recommend, or is there any?
well, everything that you additionally use in a language will hit performance a little bit. I would be very surprised if you could notice that. Because with any property that has read-only on it, it already has to be a type property. So the performance hit comes from the type checking, not from the read-only checking. Because that's just a single comparison saying, has this property been written to yes or no? And doing a if check on a single bit, it's pretty quick. So no, I don't think you can notice it. I haven't tried it yet, but I'm pretty sure you can notice it. Yeah. Yeah, one here. All the way in the front.
I was just wondering if there's been any discussion, because of a lot of the recent type changes, about improvements to the reflection type API. Because having used the reflection type specifically, it's really not developer friendly at the moment. But I haven't seen any proposals. Have you heard of anything?
So, yeah, I will.
Okay, I'll do it with the
I will summarize
microphone
it too.
closer.
So,
are there any improvements to the reflection type APIs? Because with a lot of the recent type changes, it's got quite confusing.
yes, it's gotten more confusing with the reflection with all the different complicated types, because we need to make sure that we also don't break people making use of the reflection classes. But because we get now nested types and things, it gets really complicated to use. It broke all of your code, I'm sorry. That is of course never our intention. But yeah, they are complicated, and we're trying not to change the return if we don't need to. Coming up with a better API for it at some point makes sense, but by redoing an API, you'll definitely end up breaking lots of people's code. So I don't think we'll see that in any PHP 8 version, but redoing reflection for types for PHP 9 is something I can definitely see showing up on the roadmap.
Yeah, it's interesting. There is always that trade-off, isn't there? Do you improve the API but risk breaking code everywhere, or leave things as they are, but then you don't have that feature and you have to wait much longer for a major release? But okay, I think
20 seconds.
I think that is, yeah, I think we have time. If there's a quick question at all, I think that is good. We are done. Okay. Thank you, Derek. Let's get another hand for Derek. Thank you.
Thank you for being here.
any other talks, then now's your cue to embarrassingly leave the room. But that's our bad. Anyway, thank you very much. I'm going to welcome to the stage Pauline. Pauline's going to talk to us about Git. Thank you, Pauline. Let's get a hand.
Thank you, thank you. Thank you for staying. Just so you know, it's very bright up here, so if you do want to leave, I won't even see it happen. So it's fine, you're fine. All right, so if not, if you do want to stay here, I hope you're ready to get legit. My name is Pauline. I'm a software engineer from Amsterdam. I am also a speaker, clearly. Mostly about Git. I have 2 Git talks. One is more of a foundational Git talk about kind of best practices and my Git ethos / methodology, I suppose. And the other one is kind of a sequel to this with more kind of advanced tricks. But this one is more of a foundational one. So if you want to get into how do I make my life considerably easier when I use Git, then this is the talk for you. That is my handle on Twitter. If you're not into Twitter, my Mastodon handle is also on there. But without further ado, let's get ready to get legit. Because I wonder if all of you recognize this state of being when you use Git. I think we've all been there, but I promise you that when we get through with this, and it will take you some getting used to changing habits, but once you do, you can go from this state to the ideal state that everyone wants when they're programming, when they feel like a hacker and their hands are dancing over the keyboard. That can happen, trust me. You'll just have to get used to it a little bit, but before you know it, it took me about like a week or 2 weeks. Before you know it, it'll be second nature, and you'll really feel like this, even while using Git, I promise you. All right, and the foundation for that is atomic commits. So hands up, I'll try to see in the crowd. Has anyone heard of atomic commits? Few hands. Keep your hand up, actually, if you're using atomic commits. Okay, sweet. Okay, so if you don't know what atomic commits are, you don't need any sort of specific type of tooling for it or anything. It's just a way to organize your commits. So if you look at the word atomic, it's something that's so small that you can't divide it without breaking it, basically. So that's kind of what atomic commits are. They're very, very small commits. And I personally feel that they have 3 sort of main features. And that the first one is that they're a single irreducible unit. So one commit only does one thing. You're only doing the one thing, one fix or one feature or one small refactoring in this one irreducible unit. So you can't break it apart any further. Then second, ideally everything works, which means that the application is stable on every commit. Ideally all the tests are green. Ideally, the tests exist. That'd be great too. And you don't break the build or anything like that. We'll talk a bit more about why that's important later. And number 3 is they're all clear and concise. So the commit messages are very clear and concise, which is a lot easier already when you keep to point 1 of every commit being a single irreducible unit, because it's much easier to say very clearly and concisely, I did this one thing in this one commit. So the purpose needs to be clear from the commit message and the description. All right, so that's basically it. Again, you don't need any sort of special tooling for this. This is just a way of organizing your commits in this way. It's really it. And it might sound simple, but it will help you with a lot of things in your Git life. And the most important one, we'll go through a few of them, but the most important one is probably keeping your sanity. Because, okay, imagine this scenario, which I know a lot of you will probably know. So you've started a task, you've branched off, a teammate of yours has started working on the same task, has made their own branch, and now your teammate has finished their work, they're creating a PR, they've merged it, and now you need to get those changes onto your branch because now you depend on that. So you basically have 2 options. Who would do a git pull and pull the changes in? A few hands. I feel like it's genuinely more more hands than that, but it's always a bit hard when it's a show of hands. It's not everyone is extroverted enough to put up their hand, but yeah. So that's a very common choice to pull changes in and then make a merge commit of those changes, because you're smushing together those changes with the ones that you have. Another option is to rebase. Are there any people who would rebase onto? Okay, the base branch, cool, quite a lot, which is nice, I think, or can be nice rather. But let's have a look at what the basic concept of both is. So when you pull and thus merge, so this is your base branch. So you'll see that there's 5 commits here, and then you've branched off and you've made 3 more commits. So basically, when you pull and merge, you're pulling the changes from these 3 commits into your branch. What a merge will do is it will compare the diff of the head of both branches, the head being the last point in time of that branch. It'll check if there's any merge conflicts. If there is, you can resolve them, and if not, it'll just make a merge commit saying, okay, I've consolidated the changes from the 2 heads of this branch and made 1 merge commit as a consolidation, and just smushes them together in 1 merge commit. So it's pretty straightforward. The only thing is, in that merge commit, it's basically kind of impossible to say what changes happened there, because you're going to have changes from kind of all over the place. There's not one thing that it's doing, so you can't really say much more than, you know, this is a merge commit. You can't say, oh, these changes are this and that. And if you keep doing this, you'll keep having these merge commits kind of show up in your history that don't really tell you much. And then with rebase, so we have the same kind of starting scenario. We have a base branch and your own branch, and you have some new commits. So with rebase, instead of consolidating the heads of these 2 branches, it's going to replay the commits chronologically, and it's going to take 1 commit and then see if there's merge conflicts with the next commit. And if there is, then you can solve the merge conflict, then rewrite your own commit so that it no longer conflicts with the one on the origin branch or on the base branch. And then that's how it kind of replays all of the commits and rewrites your commits if it needs to, so that your commit messages can kind of stay the same. But you're changing your original commits to not conflict with the other ones, if that makes sense. So like here, for instance, we'll replay this one and compare it to this one, and it doesn't have any conflict, so we'll just move that over here. And then there's this next one, and then, oh, that one conflicts with this one, so we'll solve these merge conflicts and then make essentially a new commit out of this one to consolidate it. Then the next commit is fine, and so on and so forth until you get to the end. And then you have all the changes onto your branch, but you don't have any merge commits, and you're keeping your history kind of clean and the same as you intended. Okay, so that's kind of the difference. The problem with rebase is a lot of people start using it without using atomic commits, and that's when you end up with this situation. You'll end up with the same conflicts over and over and over again, and you'll be like, why is this happening? This is what happened with me when some years ago, someone came back from a conference and was like, I heard that we're better off doing rebases instead of, but with no further context. So we all started doing it and then realized that, you know, we were losing so much time with this specific problem that it wasn't productive at all, and we just gave up. And it wasn't until years later that I realized why this happened. Okay, so that brings me to the next thing. We'll get back to as to why this happens in a second. But the next thing atomic commits are very good for is history. So when you organize your commits in this way, it's going to be much easier to kind of see what happened in your history. It's going to be much cleaner, but also you can start time traveling very confidently along your history. You can go back in time, and you can be pretty confident that the application will be in a stable state. You can check checkpoints and timeout and start your application and know that it won't break and things like that. And it's just much easier to see what happened, basically. So one thing that people kind of automatically start doing when they start using Git is they start seeing commits as kind of save points, which makes a lot of sense because we're used to that from a lot of software. So like, for instance, in video games, you make a bunch of progress, and then you're like, okay, I need to get to a save point, because if I die now, then all my progress is lost, right? So it's like a chronological kind of checkpoint thing. The same with things like Word documents. You type a little bit, and you're like, oh, if my computer crashes now, I'll lose everything, so I need to just type a little bit, save, type a little bit, save. And so that kind of feels natural, so that's how you start using Git. You do a bit of code, you save, commit. You do a bit more, and then you commit again. And then what you end up with is kind of these checkpoint commits that represent kind of time. But the way Git is designed makes it so that's not super ideal. Let me show you what I mean. So this is an example of those checkpoint commits. Just start at the bottom. There's a bug that's been reported, and you set out to fix it. So you fix this bug, you commit it, and then you realize that by fixing the bug, you broke something else, which is classic. So then you're like, okay, I gotta fix that and commit that, and then you go fix the fix, and then you create a PR, and someone rejects it, and then you'll address the comments, and you'll say, addressed comments, because that's really all you can say about it, and so on and so forth, until you kind of end up with this. And there's a few issues with this. Namely, first of all, that in a lot of these commits, the application is captured in an unstable state, so it's going to be broken in more than one of these commits. Another one is that outside of the scope of this PR, people won't know what happened here. Address comments doesn't mean anything outside of the scope of this PR, right? So it's not going to be easy for people to understand what's going on there. When initially what you set out to do was you wanted to fix the small bug. Right? And this is also, this kind of checkpoint behavior is also why you get the same conflicts if you rebase with these checkpoint commits. Because the thing is, if you look at all these commits, there's going to be, you're going to be working in the same part of the code over several commits. Because here you were fixing a small bug, and then here you were addressing comments, so you're probably working in the same exact part of the code, right? So if you start rebasing and it starts replaying, and you have a conflict here, you're going to have the same conflict here, because it's going to replay that one, and then that one, and then that one, so you're going to have to solve the same conflict over and over again. Okay, so how do we ensure that we can organize our commits so that we can really communicate that, hey, this is what happened, this is what we wanted to do? Well, in this case, we can use amend, which looks like this. So here you'll see that we have these two commits here, and I'm going to just make a quick change. So that's in my unstaged changes, and then I can stage it, and then simply git commit -- amend or -- am. And then it'll open a swap file, which is literally just a temporary text file. It'll open in your default text editor, and it will let you edit the commit message. And then if you save and quit that, Git will parse it. So a lot of how Git works is through these temporary text files, these swap files. So it'll parse a file after you save it, and it'll do whatever with that, depending on what you're doing. And so it will do things based on what you've written in that swap file. So in this case, it opened a swap file with the commit message that you were amending, with the commit message of the commit that you were amending. So you can change the commit message, and then when it gets saved, it will parse it, and it'll change the commit message. Okay, so this is how you can add changes to the last commit that you made. So you can just keep going add it to the last commit, keep going, add it to the last commit. And that's one way you can kind of organize so that everything is, all the changes are in the unit that you intended them to be. But what happens if, you know, in the previous example you had 5 commits, right? And there's someone's requesting changes that are relevant to different commits. So not just one commit, but maybe your last commit and your third commit from the last commit. Amend won't work because with amend you can only amend the last commit that you were working on. So in that case you can do an interactive rebase. So we already talked about rebase just now in the context of rebasing onto another branch, but you can also rebase onto your own branch. And you can do it interactively. So what we were just talking about before was Git replays the commits for you and checks if there's conflicts in this and that, and then just goes through it like that. With this interactive flag, so it's either --interactive or -I for short, you're doing the same, but you get a little bit more control over how you're replaying the commits. And that's what this looks like. So if you add the interactive flag, it'll open another swap file. So again, just a text file opening in your default text editor. And here you'll see the commits that it's going to replay in your rebase. And you'll see that it's prefixed with the word pick there. And here you'll see a little legend. You'll probably, if you try this, you'll see a bit more, because this is an older version of Git, and since then there's been more commands that have been added. But you can replace that pick with anything from this list, and then tell Git how to replay it in that sense. So pick is the default behavior, so you just replay and do nothing with it, essentially, unless there's a conflict. Then R for reword is just gonna open that swap file with the commit message, so you can change the commit message if you want. Edit gives you a lot of control because it basically checks out the entire commit as if it was your head, basically. And then you can add more changes, reword it, anything you like. Then squash and fix up are kind of similar, because what that does is it takes the commit that you're prefixing it with and smushes it into the previous one, so it makes one commit. The only difference is that with fix up, it'll just automatically take the first commit's commit message, and with squash, it'll open a swap file with both of the messages, and you can either choose one of the messages or you can create a new one for this joint new commit. Then exec is an interesting one because you can add a script to this commit that it will run. So for instance, if you want to ensure that certain commits pass linting or something like that, or you want to run tests over a certain commit, you can use that one. And then drop is kind of there for, I guess, for to be more expressive, because you don't actually need drop. You can simply remove a line to drop a commit. But what it does is it removes the entire commit and all the changes that were made in it. That's what an interactive rebase looks like. And again, you can do that onto your own branch as well, like this. So instead of saying git rebase -I other branch, you go git rebase -I head, which is the current moment of your current branch, ~4, meaning I want to go from my head until 4 commits ago, basically. So this is what that will look like if you do the whole thing. So you'll see I have some unstaged changes here. I'm going to stash those for later, and I'm going to enter my interactive rebase, and I'm going to go back 5 commits. And here I'm going to say I want to edit this one and this one. So it's going to start replaying, and it will stop at the first one I wanted to edit. Then I'm going to get my stash back and stage that. And when I git rebase -- continue, it will treat it as though I've run git commit amend. So it will amend that commit with these new changes that I staged, and I can change the commit message. Then it will replay the rest and stop again at the next one that I wanted to edit. And I can make some new changes, stage it, add it in the same way, and then git rebase -- continue. And then that was the last one that I wanted to edit, so it's done replaying, and you're back at your head. And now you've essentially rewritten history. One small side note is that because you're rewriting history, the way Git identifies commits is by commit hashes, which are generated from the delta, the diff. So the changes that they introduce. So now, because you are adding different changes to a commit, the commit hash is going to change as well because the delta has changed. Now your origin, if you've already pushed to your origin is going to think, hey, this commit doesn't match with what I have here. So if you attempt to push it and it was already there, it's going to say this didn't belong here, and it will reject your push. So what's the solution to that? You have to force push if you start doing this. And some people might think that's very scary, but I'm here to reassure you that everything's okay. But we'll get back to that. But don't worry, this is normal, expected behavior for you to, if you start doing atomic commits, it is totally fine and normal to force push. But there's some conditions, but we'll get back to that. Okay, so another thing atomic commits are going to help you with is code reviews. So when I started working with Git and GitHub for me personally at the time, I would go to a PR and I would go to the files changed because you want to see what files changed. So that's where you go. But the problem with that is, like in this case, there's 30 files that were changed in no particular order with no context other than the PR description. So it's a lot to review. In no logical chunks or anything like that. So I don't know if you have any focus problems. I do. But if I start reviewing something like that with no clear structure, I get scrambled brain and I have to start over again 5 times because I don't know what I'm doing. So it's going to take me a lot longer to review. It's not going to necessarily improve the way I review or the quality of my review. So it's not a fun time for anyone. Now with atomic commits, instead of looking at the files changed tab, I can start reviewing commit by commit. So I can open the commit tab, and what I tend to do is these days you have like navigation shortcuts, keyboard shortcuts as well, I think, in most things. GitHub definitely, GitLab I think as well. But yeah, what I tend to do is I just open each commit in a new tab and just go tab by tab, basically. And what's so nice about this is because you've given everything a very clear message, you can just get the context from the message of this one small logical chunk that you're reviewing and then move on to the next. And the reason you can't do that if you're not, well, you're free to try, but the reason it doesn't really make sense to do it that way if you're not using atomic commits, if you're using these checkpoint commits, where you're committing in a time linear fashion, is if you're reviewing something and you're at the first commit and you're like, oh, this doesn't make sense, I'm going to request some changes, and then it turns out that they actually already fixed it in the 5th commit. That's not a super efficient way of reviewing, right? And with atomic commits, you're not going to have that because everything that pertains to a single commit is going to be a part of that commit because it's been amended, if that makes sense. So that's another very nice thing that you can then kind of have a much more structural, brain-friendly way of reviewing. And a little bit about commit messages. You'll see here that I have this nice little short block of context, which is very helpful in reviewing. But there's, of course, many different ways to write commit messages. There's, a lot of people will prefix a commit message with feat or fix, like for a feature or a fix, or some people will add the task number for their task manager, for instance. There's also Gitmoji. I don't know if you've ever seen that. That's pretty popular in a few like open source kind of environments where they prefix everything with a little emoji meaning something. So like a little cogwheel will be like, oh, there's some configuration changes. It's kind of fun. You'll get a very nice, colorful history. But I think the most important thing is to have kind of a team consistency. So to have sort of an understanding of what your commit messages look like. And I do find that there are a few rules that are really handy to at least apply. So that's from this blog post, which should still be here, which is quite nice. If you want to have a look at it, there's some handy stuff in there that I'm not covering. But these rules are from there. So one of them is to separate a subject from the body with a blank line. And that is, we'll see in a bit why that's a very good one to keep. Then limit the subject line to 50 characters. The 50 characters is a little bit arbitrary, but at least like limit it to some point, not only to force it to be a little bit concise, but also because of the nature of reading something in a terminal that things might get cut off. You'll see that in a second as well. Ooh, a bit too far, sorry. Capitalize the subject line. I find it a little bit easier to read if you do apply this, but it's a little less important, I think, probably, as is this one. This one is also a little bit more arbitrary. It saves you a character. But I think that one is, but this one, I think, is a lot more efficient than you might think at first glance. So use the imperative mood in the subject line. So instead of going fixed, created, or fixes, or you say create, add, fix, and it just reads a lot more directly. So it's more friendly to the brain if you're going through these lines, and you can read it in that fashion. It's just easier to parse somehow. Wrap the body at 72 characters. Again, the 72 seems arbitrary. It actually has historical reasons because the terminal window used to have 72 columns. Now it doesn't really matter if it's 72 or 75, but it is good practice to wrap it like that. So, because before you saw the commit message, that it was kind of a little box shape. A lot of views that you're going to have the commit message in, if you don't wrap it, it's just going to go on and on and on and on and on and on, and you might have to like horizontally scroll, and it's really hard to read. So it's quite nice to just have like a very limited space to read where you wrap it. And this one, I think, is the most important one, IMO, which is, I have to always kind of explain it because I don't think it's super clear from what it says. So it says use the body to explain the what and the why versus the how. What that means is the what and the why is important, and the how, the technical how, isn't super important. You don't have to, for instance, say like, oh, I added a method here that decorate, blah, blah, blah. Like that doesn't really matter that much because that's reflected in the change itself. But what someone that's looking at the history is interested in is what changed and what are the justifications of these changes? Why did you change it? So that's really important in review, as well as like if you run into like some unexpected behavior, for instance, and someone has a look at it and they can see why this was changed, that can be really helpful. So what I always do is the what is the subject line, and then the justification is in the rest of the message in the description. All right, so you might think I don't feel like manually counting 50 characters for a subject line and 72 characters for wrapping my lines, and that is totally fair. So here is, this is specifically for a combination of Bash and Vim, but here is some configuration by my good friend Luis Cabucci that will help you automatically wrap the lines. And it also has some other stuff that I've taken out of it, like spell check and things like that. But there is some really handy configuration in there. Also, if you use something like Oh My Zush, which I also do, I never know how to pronounce that. I feel like it's one of those things that a million different people pronounce in different ways. But Oh My Zush also has this sort of stuff already in there. So that's very nice. So this will end up in these sorts of views. So you have git log, which will show you the entire commit message. And then you have git log -- one line, which is one that, I'm not sure if that dash in the middle is supposed to be there. I always forget if it's supposed to be there or not. Anyway, try it, and one of them will work and one of them won't. But I use this one a lot to get a really quick overview of where I'm at, especially in organizing my commits, as just like very quick identifiers of like, oh, this is what happened there. And this is also, now you can kind of see why it's important to limit that subject line by a set of characters, or a set number of characters, and why it's important to have that blank line in between. Because if you don't, this view might have part of the description in it, and it doesn't really read as well. So here you have like this really succinct kind of subject line. And here, if you want more context, there will be like a very clear distinction between, oh, this is what happened and this is why I introduced these changes. So, some other quick wins. It's now really quick wins in terms of atomic commits. It's when you're using atomic commits, it now becomes easier to, for instance, cherry pick, because everything is packed into logical compact units. It becomes much easier to cherry pick a commit from somewhere without having to worry about what other changes they're tied into and what other dependencies these changes have. And if you don't know what cherry picking is, it is being able to go to a different branch and pick a commit and drop it into your own branch, which can be really nice if you're working in parallel with someone and you're kind of dependent on some of the things that they're doing, but not their entire branch, so you don't have to rebase onto their branch, but you can just simply cherry pick this commit for a little bit and use it. So this is what that looks like. Yep. So let's say I want this commit. I can go back to my own branch, and I'll see that there's 2 commits there. And then I can git cherry-pick and paste the commit hash in this case. You can also use the shorter ID as well. And then it's on your branch. Simple as that. So that now becomes much easier, and you're much less likely to have conflicts when you cherry pick, and if you do it, usually is much easier to deal with. So that's quite nice. Oh, that's a lost slide that wasn't supposed to be there. Okay, another thing that becomes very easy is dropping stuff. So dropping stuff is something that you think you won't need to do a lot, but once you start doing these atomic commits, you realize that it's actually super handy. And specifically, in my case, I always use this example because it was super handy at the time when typing was introduced in PHP. So like argument types and return types and things like that. We started like implementing this rule that anytime you touch a file in our code base, while you're there, you introduce typing as well. So what I would do is I would go to this file to do whatever I need to do, put that in a separate commit, and then also add the typing and put that in a separate commit as well. And then what would often happen is that because there was no typing before, then you run your integration tests and things like that, and it turned out that you were passing the wrong types in certain places, so it would break stuff. And instead of then going down this rabbit hole and having to fix it and everything, I would sometimes decide, okay, this is a problem for later. I'm just going to remove this typing for now and just do the changes I was set out to do. And the thing is, if I would have put that all in the same commit, I would have had to manually go back and change everything back. Whereas if you keep it organized in a separate commit, you can simply remove that commit and then you're done. It's 2 seconds, as opposed to like, well, depending how many things you added, but it could be many minutes. So it was a huge time saver. And this is what that looks like. So we're going to go into our, let's say I want to drop this. We're going to go into our interactive view base, and we already saw that drop command before in the legend, right? But you don't have to use that. You can just cut the line. So in Vim, it's dd, and you cut the line, and then it's also gone. So you cut the line, then you save the file, quit, and then the commit is dropped. Super easy. Now the next thing that I want to talk about is a fun one, and it's called bisect. And I usually use an egg or a bunch of eggs and a building to explain what that is. How many of you have heard of bisect? How many of you, keep your hand up if you've used bisect. Yeah, so I always like talking about this one because a fair few people know about bisect, but it's kind of a mythical beast that people kind of have heard about it being very fun and cool, and I can confirm it's very fun and cool. I love bisect, but it's one that seems a little bit if you don't understand what's happening, but it's actually not that complicated. So to illustrate this, let's take this bunch of eggs and this building, and let's say someone tells you, hey, I want to know which floor on this building is the first one that I can drop an egg from and it won't break. So let's say these are magical sturdy eggs that won't drop on the ground floor. We're going to take one egg, we're going to try it on the ground floor first. Okay, it doesn't break. Then we're going to take the second one, go to the second, take the first flight of stairs, drop it, doesn't break, and then you keep going up one by one, story by story, until eventually it breaks. But let's say this building has like 50 floors, and these eggs are very sturdy. It might take 50 iterations for you to get to the point where you know it's going to be the first floor that breaks the egg. Another strategy, which is more efficient, is to start in the middle. Because if you start in the middle and it breaks, you already know that the first floor that it's going to break on is between there and the ground floor. So then you go into the middle of that, you see it doesn't break there, so you know that the first place it will break will be between there and there. And then you keep going until eventually you're out of iterations. And that statistically will take many less iterations than doing it one by one. And so that's also why it's called bisect. Bisect stands for cut something in half. You also might know this strategy is binary search if you're a CS person, which I'm not, but you might know by that term. It's a similar strategy. So instead of using this for eggs that are magically unbreakable, you can do this in your code base as well. So if you want to find a point in time, so you could either go commit by commit, you could check out a commit and then check out the next commit and see what happens, or you could take a point in time and do this strategy where you take the middle one and then do it like that. So let's say you have this scenario where you have a website and there's a button that used to be in the middle, and suddenly a month later you look and the button is now here. There's no tests covering it or anything, so you don't know when this happened. You can use bisect to find the point in time, the culprit basically that moved the button. Okay, so let's say we already know that a month ago and which commit is the button was still here in the correct place. You can start your bisect by saying git bisect start. You can give it a good commit, either by ID or by hash. Git bisect good and then ID, and then git bisect bad will, by default, will take your head. So your current point is a time. Then it will, I'm going to do it again because I feel like this is always a bit too fast. So we're starting our bisect, right? We're marking a good point in time and a bad point in time, and it will check out the commit in the middle. Then you can check it when it checks it out. So you refresh the page, let's say, and then the button is in the right place. You'll say, okay, git bisect good. And then it will keep checking out commits in the middle, and you'll keep marking them as bad or good. And then eventually, here you'll see 0 revisions left to test after this, and then when it's done, it will spit out the first bad commit, and to get out of the bisect, you go git bisect reset. And so you've really quickly, instead of having to trawl through all these different commits and then try to kind of make out what happened from the commit message, you can really quickly find the culprit in this case. And the reason you can do this much more easily with atomic commits now is because anytime you check something out, it's more likely to be stable. So it's more likely that you can actually refresh the page and it works, and you can ascertain that, like, okay, this is all okay except for this button. This is the wrong part. This becomes especially important if you want to run bisect automatically, which you can also do. If you are interested in that, there is an advanced Git talk that I do that is also online. There's a tutorial where you can try it out. That is super fun. I'm not trying to be dorky here, but that's why I love bisect. When you run it automatically and you let it find bugs for you is really, really great. Okay, so That's the last good thing about atomic commits that I'll share with you. But before we go to questions, I want to kind of preemptively take some concerns away. So you might say, but how do I call people out on mistakes? Because you're rewriting history, right? So you can't like look at a PR and go, oh, you broke the bug fix here and then you fix it again later. You got to kind of consider what the purpose of source control is. Is it to really be able to kind of point fingers, or is the main idea to capture your application in a certain state and to be able to see what happened over time? So yeah, I think the pros of using atomic commits far outweigh the ability to kind of be able to see exactly what happened when in the scope of like a PR, for instance. Then, how will this affect my workflow? Because you might think that, okay, all of this reorganizing is nice, but it does take longer than simply typing something, committing, typing something, committing. And yes, it does take a little longer at first. After a while, it becomes so second nature that it really makes everything easier, and it actually becomes a time saver. But I do acknowledge that sometimes, especially on a Friday, you might want to just be able to commit a messy commit and push it and not worry about getting sick on Monday and then nobody can continue onto your branch, for instance. But you don't want to take the time to organize everything then and there. So I do this a lot, actually. I often make like one big checkpoint commit and then I reorganize it later. And there's a few different kind of strategies that are all quite similar, but this is the way that I do it. So I have a massive checkpoint commit for a day's work. And then what I will do is I do a soft reset of that. So that will undo the commit, but it will still keep the changes in that commit in your unstaged changes. And then I can start organizing them bit by bit into. So I come back to work on Monday and I do this. So I'll reset it, and then I'll see here, oh, there's, let's see what the last commit was. That's built some handler. So we could already know that this handler file belongs to this commit. I'm going to amend that commit, and then I'm left with some more changes, bug fix, and 2 files that are relevant to feature X somehow. Of course, in real life, you will have your own context of what you were doing, so you won't need to look at it that way. But then I'm going to go add these 2 feature X things. I'm going to make a temporary commit just for my own reference. Just call it feature X. And then the other one, I'm going to do the same thing. So I'm going to add this bug fix thing, and I'm going to create a temporary commit for that, just for my own reference. And then I can interactively rebase. And then by cutting and pasting the lines, I can move the commits up or down. So I'm going to take this feature X and put it next to the commit that it was supposed to go in. And the same for this bug fix thing. And then I'm going to change pick to F for fix up. And then it will take the temporary commit and just throw it into the original commit, and then it's where it was supposed to be. So that's how you kind of organize and rewrite history, even after you've already made this checkpoint commit. So you can just go back and organize it after the fact. Then the last thing, isn't force pushing scary? Yes, it can be. For one, I think it's always important to have your main branch protected against pushing and force pushing. I think your main branch there's no reason to push to your main branch. If there is, there's probably something that you might want to look at with your branching workflow. So always protect your main branch against force pushing. And what I like to do is I always work on my own branch. I never share a branch with anyone. That's just, I enjoy working that way. There's no reason for me to share with anyone, because they can have their own branch and rebase onto my branch if they need to, and vice versa. So there's never really any reason to share my branch. And then so when I force push onto my own branch, and I can't accidentally force push onto the main branch, for instance, it's fine, because that's just my own work. I'm not overriding anything. So I'm never scared to force push onto my own branch. If you do share your branch with other people, there is also the option, and a lot of people like to set an alias for this, instead of git push -f for force, you can git push -- force with lease. And that means that it will force push for you, but before it does that, it will check if someone else has actually already made commits onto that branch, and it will still reject your force push. If that's the case, it'll say, wait, somebody else already pushed to this branch before you, so you have to rebase onto the origin first before I let you force push. So that's another way to kind of circumvent that. This is a very, very common way of doing this if you're using atomic commits. And I hope that addresses your concerns, but if not, feel free to ask me any questions. If there's enough time, I hope so. There is.
There is plenty of time. Anyway, should we just say thank you to Pauline? Thank you.
Thank you.
Yeah, we have about 10 minutes or so we can do some questions. Are there any questions from the room at all? Alternatively, you can drop it into the channel in Discord, if you're on Discord.
Really trying to look
One right at the very back.
Oh, there is.
Get my steps in. Whilst I'm walking down, I'm actually going to ask a question, which is, when you first start a project, there's that inevitable, you do a load of work and you've got this kind of initial commit.
Wait, can you speak up a little bit?
You've got this, there's inevitable that you do a whole load of work at the
Yeah.
beginning of a project, and I always find it very difficult to get into the habit of atomic commits right at the beginning of a project, and you just get that kind of initial commit dump of everything. Is there a good way of sort of following the same steps there, or would you recommend
For
something
the
different?
initial commit?
Yeah.
I mean,
when do you draw the line?
I usually, when I start something, I usually just start with a README, and then that's my initial commit. I don't think it's necessary. You're saying specifically if it's a giant commit?
I mean, yeah, it's something I see quite often. You'll
Yeah,
get
I think a lot of
a large chunk of work goes in as an initial commit, as
Yeah,
opposed to being atomic from the start.
Yeah, I think that giant initial commit usually tends to happen when someone has started working on it by themselves, and they're like, none of this nonsense when I started by myself needs to be in the history necessarily, so I'm just going to squash all of it and set it as the initial commit. I think there's nothing wrong with that. I think atomic commits become more important when you're working in a team, because it makes collaboration just a lot easier. So I think if you're just by yourself, there's not really that much need to do it. I still like to do it because I just like organizing my stuff, but yeah, I don't think there's necessarily anything wrong with that.
Okay, thank you. Right, back to our first question.
I feel like I look really silly just like peering out into the sun.
Hi. I had two questions, if that's okay.
Okay, yeah, no worries.
First of all, in terms of the peer reviewing process, you say you go through the tab and you review from the commits rather than the files.
Yeah.
It makes sense in theory, but I think unless you've done everything perfectly to the T, you'd end up wasting more time, because unless everything's perfectly in each own commit, you'd review things multiple times. I wondered if you had any personal experience with that. Does it happen a lot with your team?
Sorry, can you repeat that last bit? Because there's like quite a bit of echo. I don't know if everyone else has
Yeah,
trouble
sure.
hearing me.
So in your experience, when you reviewing people's through their commits, unless they've got everything perfectly into their own specific commits, do you end up having to review things multiple times?
Yeah. So this thing kind of really only works if your whole team is doing it. And then it definitely does save a lot of time and makes it a lot more organized. But yeah, if I have been in situations where not everyone on the team kind of agreed on it, and then it doesn't really make sense. There does need to be a team understanding that that is the strategy that we follow, and then it'll be a real time saver.
Okay, thank you. And for my second question, the way that we work is, I mean, in principle, everything you're saying makes sense, but then when we merge into the master branch to go to production, we do a squash commit.
Yeah.
Because then we'd feel that if there was a problem with that deployment, we can just revert that single commit.
Mm-hmm.
So at that point, all of this effort to split the commits out essentially feels wasted, maybe, because we've deployed to master. So the master's all squash commits.
Yeah. Yeah, that's actually a very common thing people do for various reasons. Like one of them is to be able to revert one single commit. Small side note: you can basically achieve all of that as well if you tag your releases, for instance. So you don't necessarily have to do a squash commit to be able to do all the things that you would if you do squash merge. That's one thing, but I don't think there's. I think that's a matter of preference. Personally, I also don't mind if it's squash merged, because I do think that the biggest advantage, most of the advantages that you get are going to be in the context of collaboration. So if you're still actively working on a branch and you have to rebase onto someone else's branch, it just becomes much easier if there's atomic commits. If everyone's using atomic commits, and also for clarity within the scope of a PR. One thing that I do think, I do have a slight preference for keeping the commits atomic even on the main branch, and that has to do with bisect. Because the more granular your commits are, the easier it'll be to find a really granular set of changes if you do a bisect. So that's I think the one reason, and I use bisect a lot. It's once you're used to it, it can be really, really handy. So that's my main reason for preferring no squash merges. But yeah, squash merges I think are also very valid.
That's great, thank you.
No worries, thank you.
Okay, any more questions from the floor? Yes,
yeah,
down
they're
the other
making you
end.
run.
Yeah, this is turning into a workout.
They're making you travel.
Or are they plants? Have they planned this in advance, haven't they? Okay, so we've got 3. I'm going to go with the nearest first. Here you are.
I'll try to make the answers brief.
Hello. I don't know if there is an answer to this question, but I'm just interested in your thoughts. The ideal is to have every commit be a commit you could go back to, and that is a working state in the application. Sometimes you've got something into master, which you then find out has a bug, and you need to put another commit on top of it. Do you ever, where do you stand on the rewriting history versus the fact that there is a commit on master that is in a broken state? Yeah, so I do think that when something is on your main branch and it's on production and stuff like that, again, I mentioned before that I don't see that there should be a reason to push to your main branch. I think once something is on your main branch, that is a public branch. It's been published basically, so you don't change that anymore. I also feel like the capturing every commit in a stable state is a nice goal, but I also don't think it's the be-all end-all of atomic commits. It's a nice goal because it has some advantages, but it's not always possible. And you're always going to have unexpected behavior. Short answer is don't rewrite your history on your main branch. Yeah, does it make sense? Okay,
Hi, yeah, so I very much work with the checkpoint style you described at the beginning. And my IDE makes it quite easy to work like that. So I don't use the command line very much. Mm-hmm. So do the usual suspect IDEs work well with this setup?
Well, I'm mostly PHP Storm. I think most of us are. I've really always worked with Git on the command line. That's just what I'm used to. So I'm not super well versed in how PHP Storm, for instance, does it. But I would imagine it's fairly similar in the sense that the merge conflicts that you do have, although from what I understand, it's quite easy to see the diff and kind of pick which side you prefer and resolve it in that way. The merge conflicts when you use atomic commits are just going to be vastly more simple, and that's the thing. So even if you're using your IDE and that makes it a little bit simpler, you're going to go for merge conflicts that span like 10 lines, for instance, to maybe sometimes having one small merge conflict here with a lot less like context that you need to be able to solve it. So that's more the advantage.
How far back in time do you go when you're kind of rebasing? So if you've been working on something for a week and at the end of this week you are making a change to a method in a controller that you built on the first day,
yeah,
do you then squash those first and last commits together, or do you go back through the whole week's work and reorganize it, or where do you draw the line there?
Yeah, I do, and that, like the way you've phrased it, does sound like it's cognitively a heavy kind of cognitive load. In practice, that's usually not the case, because in practice, what happens is you really know where everything kind of belongs. It's kind of hard to convey now, but yeah, it's usually pretty easy to classify. Oh, these changes just should go in this commit. And I also tend to not have very big PRs, so I'm a big proponent of having very short-lived branches with, you know, not too many commits. But yeah, so I basically, until it's merged, I tend to organize my commits atomically.
Any more questions? Got another few minutes.
One more.
Yes.
You're also patient, thank you.
Yeah, so how we usually work is we try to like also keep like short PRs and like make them short, but we won't rebase the stuff in a PR because then it makes it hard to track which comments have been addressed and reviewed.
Yeah.
But then we will just squash the PR and make that the atomic commit into the main branch and like try to keep the main branch as atomic. Like, what's your opinion on that instead of rebasing your PR, which will possibly lose information of who, like, if a comment has been reviewed, like, addressed or not?
Yeah, so that's another reason some people prefer squash merging and not really keeping it for code review purposes, right? Because if you're rewriting commits to address comments, then the reviewer might have to like go through every commit again. There are, I think GitHub has like I think it's GitHub or GitLab, I can't remember which one, but it does have a view of like, oh, there's been a forced push, but this was the previous version. So there are those that have a view like that. But also it's a really common strategy for teams who do use atomic commits, but still want to be able to see the changes after the PR was already open. They will make fix-up commits. So instead of making a regular commit, they will go git commit -- fix-up, and then add the ID of the commit that it kind of belongs to. So then in the PR, it will show up as a separate commit, so you will be able to kind of really easily see like, oh, this is the new ones after I already reviewed it, sort of thing. And then after it's been accepted, you can then really easily, through kind of the cleanup strategy that I showed, but a slightly different command, you can go into an interactive rebase and add the auto squash flag, which will then automatically take those fix-up commits and squash them into the commits that they belong to. So you can still organize it before you merge in that way and still be able to see the separate commits. Does that answer your question? Brilliant. Sweet.
I think we've got time for one more question.
If there's no other question, by
If
the
there's
way,
no more questions.
I would also like to show you this
there we
QR
go.
code with the cheat sheet so that you can go to the cheat sheet so you won't have any trouble remembering all the stuff that I showed you before. So hopefully that's helpful. I think that's, is that it? Or
If that's your last slide, yes.
That is my
Thank
last
you.
slide.
Thank you, Pauline.
Thank you.
So we now break for, gosh, it is bright up here, I see what you mean. We now break for lunch down in the King George room. It's